Solving the integral e to the power of x multiplied by cosine x dx. First we use integration by parts. U is equal to e to the power of x du equal to e to the power of x dx. dv is equal to cosine x and v would be equal to sine x. Now set this is equal to I u v minus v du would be equal to e to the power of x sine x minus the integral of e to the power of x sine x dx. Set this as j for example. Do another integration by parts, as a would be equal to e to the power of x for example, and dA would be equal to e to the power of x dx. T equal for dt as sine x, t equal to minus cosine x. So j equal to at minus t dA would be equal to the following: e to the power of x minus cosine x minus e to the power of x multiplied by cosine x dx. Then we just go back to the first integration by parts, which is also equal to I. Set I as equal to e to the power of x sine x minus j for example. So integral of ex cosine x dx would be equal to e to the power of x sine x minus the j, which would be minus ex cosine x minus integral minus e to the power of x cosine x dx. Now we know that two negatives cancel out, so this is a positive. A negative comes here, so it stays a negative, and this becomes a positive. So we get, I need for this one, e to the power of x sine x minus, which would be plus e to the power of x cosine x minus integral of e to the power of x cosine x dx. Now we add the integral to the other part of the integral, which is the I we substituted in the first place. So we get 2e integral of 2 multiplied by the integral of e to the power of x cosine x dx, which would be equal to e to the power of x multiplied by sine x, etc., plus e to the power of x cosine x divided all by 2 on both sides. So finally you'll get e x sine x plus e to the power of x cosine x divided by 2, and don't forget the plus c. This is the answer.